Welcome to Chapter 2 of General Biology. So in this chapter, we're going to be talking about the chemistry of life. So even though chemistry is associated with non-living, we talk about chemistry in this class because chemicals and chemistry is what makes up all living things. So matter is anything that takes up space, and matter can be found in three different forms, basically. We have our solid, our liquid, and our gas. So think about water. Water can be found in all three forms. Water, when it's solid, is an ice cube. As a liquid, it is drinkable water, and as a gas, it is water vapor. And so matter, which makes up pretty much everything, is made up of elements. So what are elements then? Elements are the fundamental units of matter. So elements can't be broken into smaller substances. We have found 117 different elements. 94 of them are found on Earth. And so when we name elements, we typically use Latin names to give them their symbol. So nitrogen has a symbol N. Gold has the symbol of Au, aurum. Sodium has a symbol of Na, natrium. So these are Latin terms. All living things are composed of elements. The most common elements found in living things are these six, which I call the chnops. It's the easy way to remember them. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are your six elements that make up pretty much all living things, but there are some microelements that are needed as well. Atoms then are the smallest part of an element that display the elemental properties. And atoms are composed of three subatomic particles: protons, neutrons, and electrons. Protons and neutrons are found in the nucleus of an atom. Oops, there we go, in the nucleus of an atom. So the term nucleus here means middle, okay? So they're found within the atom, and they contribute to the weight or mass of the atom. Electrons are found in the orbital outside of that nucleus. So surrounding the nucleus are orbitals, and the electrons would be found here. Okay. Electrons are so light that they don't contribute to the mass of an atom. Protons are positively charged. Electrons are negatively charged. And neutrons have no charge. So all atoms are considered electrically neutral. Because the number of protons and the number of electrons always equal each other. All right? So the atomic number is equal to the number of protons in an atom. And so an example, carbon has an atomic number of 6, which means there are 6 protons in carbon. The mass is equal to the number of protons and neutrons. And so in this case, the atomic mass, since we have a mass of 12, we can find the number of neutrons by subtracting the 6 protons. And that would give us 6. So there are 6 neutrons as well. So all atoms have an atomic number, which tells you what type of element it is, and atomic mass, which tells you the number of protons and neutrons together, or the weight. I just mentioned this about the equal number of protons and neutrons. So when we look at a periodic table of elements, then you see for every element, there's an atomic number and an atomic mass right down here. I'm not going to circle it so you can see. Masses are always going to be the average of all the different atoms. And so I'm going to go forward really quick to talk about isotopes, okay? An isotope is a variation within an atom. So isotopes have the same number of protons. So in this case, this is the element hydrogen. This is one atom of hydrogen, right? Hydrogen has an atomic number of 1. And that means it has 1 proton. And it has 1 electron. So it has a weight of 1. But there are variations of hydrogen. And so here's a variation of hydrogen that has an atomic number of 1, but it has an atomic mass or weight of 2. And here's a third variation. Still, the atomic number is the same, so it's still hydrogen, but it has a mass of 3. So the masses change. Do you see that? Deuterium is what makes up heavy or hard water. If you've ever heard of hard or heavy water, that's what deuterium makes up. It's actually D2O. Tritium is a radioactive form. So all elements have a radioactive form. So tritium happens to be the radioactive form of hydrogen. But if we take the total number of regular hydrogen, deuterium, and tritium, and then get the average weight, I'm going to go back, you're going to have an average weight of 1.00794. So the average weight is going to be the weight of all the different isotopes of that atom around. So the atomic weight then is going to be very close to the most abundant form of the atom. And so for hydrogen, this is the most common type of hydrogen atom. And so that's going to be the most common. This is going to be the least common. Deuterium is in the middle, okay? And here's another example showing carbon. Carbon has an atomic number of 6, but carbon can have 12. So it can have, for neutrons, it can have 6 neutrons. It can have 7 neutrons. And I think it's 6 and 7. So carbon, and 8, sorry. So the most common type of carbon, again, is this form right here. Radioisotopes then are the heavy isotopes that tend to be very unstable, and they are in general going to be decomposing very quickly to a more stable atom. So every single human has radiation in them, and all materials can potentially be slightly radioactive just because atoms are constantly deteriorating to a more stable form. And so they can be radioactive for a period. So living cells can distinguish regular isotopes from radioactive isotopes, and this can actually cause different problems and can be damaging. It can also be used as a biological tracer for different materials in research. So we use radiation in the medical field to kill off cells that are potentially dangerous, so like cancer cells. But we also use radiation in the food industry to kill fungi or bacteria that are spoilage forms in a process known as irradiation. And this allows us to keep foods for a longer period. Have you ever noticed that when you go to a farmer's market and you get some type of fruit or vegetable, they don't stay um, good for as long as if you go to like a grocery store and buy the same fruit or vegetable? That's because the foods that you buy from the grocery store are often irradiated, and that's going to allow them to stay longer. They have a longer shelf life. I'm going to stop here on this video and we'll get into what molecules are in our next video. Bye.